This meeting is recorded and the recording may be made publicly available on our YouTube channel, so please um, don't say anything that you would not say ordinarily in a normal recorded meeting. This is the VOLTHA Pod Management and VOLTHA FCAPS Brigade. And I think what we're going to do is we'll start with status reports, and then after status reports are done, we will continue discussing the World Clock API or the on-demand API. So for our status reports, why don't we start with Onkar? Are you there, Onkar?
Yeah, Scott. So hi all. So like this talking about the status. So I have I'm trying to designing the internal part of NEM proxy. I have designed it. Also, I have identified the changes in Volta level. So today in today's call, if I could get 10 minutes of time, then I would like to present the changes and everything. I have prepared PPT for that also. So that's the status from my side.
Okay, yeah, let's do your presentation after we get the status from Ganesh and from Dinesh.
Yeah, okay, sure.
Okay, so Ganesh, you wanna let us know what you've been doing?
Yeah, hi all. I have created one. I saw some upgrade on the Prometheus package. There was a deprecated call to the handler in the existing exporter. So I made a little change about that to fix it in the existing exporter, and I have raised a review. There's a package dependency. I'll resolve it. And apart from that, regarding the deployment strategy, I'm working on it, how we can have this scalable solution. So a couple of options I explored. So probably in a couple of days, I will share the observations and my thought process on the email, and we will take it further.
Okay, sounds great, Ganesh.
Yeah, that's all, Scott.
And Dinesh, anything on the redfish importer?
Yeah, actually, we have pretty much finished most of the coding, and two of the Helm chart Garrett's needs to be merged. So one of the Helm chart Garrett I had sent long time ago. I'm working with Zach on getting it committed because they were busy with Seba 2.0 release. So and then Helm chart changes were affecting all other modules. So we sorted that out, and I think today or tomorrow he will check in the code, and then there is on basis on that there is another Helm chart Garrett is there where we need to expose HTTP port and gRPC port to outer modules. So that will be done soon, and then we are ready for integration. And then there is another point. Maddie had sent a mail regarding how much and which data needs to be collected, because what is happening is when you give chassis API to the Redfish server, it gives you number of chassis. Then you have to go on in the loop and collect the data for whatever chassis number it has given. Suppose there are 3 chassis, then you have to collect data for the 3 chassis. So when we give it to the exporter, shall we give in the way we are collecting the data, or do they want in any other format kind of thing? So she had sent a mail but didn't get any response. So I need to resolve that also.
So is that something you need direction from the operators to figure out the requirement, how they'd like what data they'd like collected and how they'd like it posted?
Yeah. Operator or whoever is working on exporter, how they want to present it, and in what format it needs to be collected. Like when you collect systems data, there is a hierarchy. So my impression earlier was when you collect system data, it will give all the system data, but I don't think it is like that. And today Maddie was supposed to dial in, but for some reason she couldn't, I think. So if someone can respond to that email thread, then I think we can discuss on email as well.
Okay.
Which email thread we're talking about?
There is one Scott had created for pod management, so I think she responded on that where everybody is there.
So Scott, there's a separate mailing list.
Not, it's a thread.
Oh, okay.
Yeah, I'm assuming this is the normal pod management API discussion thread. Let me see if I can pull up the tail of that thread.
And the person who sent, her name is Maddie Cheng.
Yeah, I don't recall seeing it. And could you spell the name?
Maddie.
Maddie.
Yeah.
Well, yeah, something is coming up in. Yeah, I don't think I'm seeing a message in that thread. Though I am seeing something July 10th, a separate CEBA 621 scheduler to collect data from importer.
Yeah, that's the one, I think.
Okay, yeah. That's a separate thread. I'm just seeing if you're on that, Sean. I don't see your name listed on that, Sean, so you probably didn't see it.
I may not need to.
Maybe not.
I may not.
Yeah, but anyone who didn't get that is called CEBA 621 scheduler to collect data for importer. Yeah, if you want to be on that thread and you didn't see it and you're not on it, just let me know. I will CC you into the thread.
It's on the Jira ticket itself?
Let me
Yeah,
see.
there is a Jira ticket for it. So that was the reference.
CEBA 661.
Is the question kind of how do we want to see multiple OLTs? Like if I have 6 edge cores, how do I want to see them represented in this, as opposed to box 1, box 2, box 3, box 4, box 5, box 6? Is that kind of the question?
No, I think the question was mainly when we give first time query, we get number of chassis. Then we have to go on deep to collect the data. So the question was whether as we collect the data, we should export the data or we should combine all the data and export it, something like that. So my personal opinion is as we collect the data, we should export it.
Yeah, I mean, in terms of AT&T's usage, what AT&T would expect to see, and how we've kind of talked about pod management, is somewhat of a serial number to a CLI name, kind of CLI code string name associated with a particular VOLTHA instance or VOLTHA piece of hardware, whatever, edge core box or whatever. And we would hope to see that based with that CLI identifier, that name, that string, it somehow gets tagged into a report that says, here's the data for this device, as opposed to device number 6. Here's your data, or here's a bunch of data for devices 1 through 6. We would kind of expect that to be separated out independently on each device, with the additional enhancement of, here's the name of the device, not just, I'm number 3, but here's my name based on.
I think what Dinesh is saying is when you requested the information for a what do you call chassis has a number of devices in it. Do we go ahead and send them separately?
Sub devices on the individual piece of hardware.
Yeah.
Okay.
We would definitely need to be able to correlate those sub devices to specific types of things. I mean, if it's this is I mean, if those sub devices somehow have to have some kind of meaning upstream, so hopefully by the definition of the box itself, those sub-devices have some meaning. So I don't know how that gets modeled, but hopefully that there's more information than just device number 6 is hot. You know, device number 6 is over temp. Oh, what the heck is device number 6? Hopefully just in the model of whatever that particular device is, it has some meaning and can be given more meaning than just a device number.
Okay.
That would be some operator's input.
Okay. Thank
you. Just curious, you know, my memory is a little bit vague here. What are the, you know, information has been collected using the Redfish? Do we have a list of the KPIs?
Yeah, it's a standard Redfish API list.
Okay. I know you have a presentation somewhere.
Maybe we can collect. Maybe we can collect and publish all the information we are collecting through the Redfish.
That will be great. Yeah, I think that would be great. If you have not done so, if you've already done that, then let me know. Then if you can, don't mind, send me some information on that.
Okay.
Yeah, I think if we had an idea of just what structure you're getting when you query this chassis, you know, what devices come back, how it's broken down, maybe that would help us visualize the issue.
Okay, sure. No, the reason Maddie was supposed to join this meeting is to clarify all those things, but I will ask her to do that on email, or she can join next Monday.
Yeah, Scott, if you can include my guest on that email too, just so I can take a look too.
Yeah, I've added Mike and Sean to that email thread, so you guys should be on it now. Anything else, Dinesh?
No, that's all.
Okay, well, I think I'm ready to turn over to Onkar for your presentation. Are you ready, Onkar?
Yes, I'm ready. Just give me 1 second. I'll share my screen. So just let me know once my screen get visible to you.
It's visible to me.
Yeah, so let me start some detailed design architecture for on-demand API service. The modules that we are covering in this session is like NEM proxy, VOLTHA core changes, and VOLTHA core adapter changes. And as you could see, we are touching most of the components of core areas. And this is the high-level design. Lastly, we have discussed. And now this is the NEM proxy, which we discussed earlier. The gRPC client will send the request, and the request will goes to the VOLTHA. And for the once the OMCI test action is get submitted to the VOLTHA through the ONU, it can get success and fail response, and that response comes to the gRPC server. After a few minutes, when it's the results get generated, the results are getting pushed to the Kafka, and we are collecting that result from the Kafka topic and publish it to the gRPC client. So this is a type of synchronous communication we have discussed in last call. Now I just wanted to show the sequence diagram, how it looks like. So there would be like, as we have discussed, the operator is going to implement the gRPC API client. The NEM proxy contains the gRPC server and gRPC client, and in VOLTHA we are going to touch on gRPC server, global handler, dispatcher, and the rest of the components. And here we have in hardware level the ONU is presented. Once the once the OMCI invoke test get heated to the NEM proxy, the NEM proxy gRPC server will get the request. It loads to the gRPC client server, and it do the connection stuff here, and it gonna call the gRPC server. And from here, it based on the device ID, the global handler will pass the call to the dispatcher, and dispatcher will decide whether to broadcast or unicast. In a single node environment, these scenarios will be considered. After that, the call goes to the local handler. From here, the local handler will decide which adapter to load. As of now, we are providing the implementation based on the Broadcom ONUs. So it will call that Broadcom ONUs adapter code, and from here we are in adapter sides. We are just trying to invoke the OMCI test action that will get received to the ONU side. The ONU will generate the response based on the success and fail, and it will like subsequently pass to the NEM proxy layer. After once the success response gets passed to the gRPC server, we have subscribed the Kafka topic over here, so that the request will go to the Kafka topic. As in 19th number, the result will come to the adapter and will subsequently pass to the Kafka topic. From here, we are going to get the result, and that result is going to get back to the NEM proxy, and the NEM proxy will pass that result to the operator like gRPC API client. So this is the success scenario for the how the synchronous communication work, and this is the sequence diagram. Currently, I have it.
So I have a question. So from when you pass back the result to the Kafka, what is the interface between gRPC API operator client and the Kafka? Will they be listening to Kafka bus?
Yes, yes. They are listening to the Kafka bus. We are going to subscribe the topic for that.
Okay.
Now, this is the failure sequence diagram. So we are going to handle the different types of failure. The first failure, as example, I have taken the timeout failure, but in future there are most level of system failures or some other failures will come. In first case, we are going to take care of that, and we are going to report it to the gRPC API client. In second level scenario, sometimes we have seen that the ONU power on and off will occur and the device is unreachable. So at that time, we are going to send the like if the device is unreachable, in second scenario, we are going to report that also to the operator, saying that for this request, we are not able to reach to the ONU, so device is unreachable. Now if we talk about the NEM proxy changes, now
so one question on another failure scenario.
Yeah.
What if your test action succeeded, but you just never got a response? The response was just lost. How do you deal with that case?
So in that case, yeah. So my assumption was the OMCI CC channel have specifically timeout we have. So at that time, we are going to check with the timeout and saying that timeout is occurred.
Okay, that sounds reasonable.
Yeah. Now let's consider the NEM proxy changes. Here we are going to implement the API.proto file, in which we are adding the service like on-demand API service. In that the RPC call we are going to implement like invoke OMCI test with the test param and return the test response. And the test param should be the device ID and the request ID. To differentiate between the multiple requests, we are going to generate a request ID for every request, so that while taking the result back from the Kafka, we can identify the multiple requests through the request ID field.
So request ID is sequentially created, or it's a random number?
It's a random number. As of now, I am thinking about it. Okay. So that we can generate it, and we can while getting the response, we can give it back. So currently, right now, I'm thinking the same. Like it is a random number. Currently, I'm thinking.
Yeah, you could make it like a UUID. There are algorithms to generate UUIDs.
Yeah, that's the same thing I'm thinking right now. Okay, shall I go ahead?
Yeah, go ahead.
So now talking about the VOLTHA core changes in VOLTHA file, as most of you are aware about it, there are two services, that is VOLTHA global service and VOLTHA local service. We are going to give support to the invoke OMCI test RPC call with the test params, and these two same thing we are going to declare here, and to handle the test param would be the device ID and the request ID. So this is like a protobuf implementation for handling the request coming from the NEM proxy in VOLTHA. Now going ahead, once the call get reached to the global handler, we are going to implement the method name invoke OMCI test. In that, we are going to call the dispatcher with device ID and request ID. Now the dispatcher will take that request ahead and check whether to broadcast or unicast. Once the call get come to the local handler will load the specific device specific adapter and call to the device specific adapters. So adapters would be the base class would be the adapter agent, and the adapter agent we are going to implement the method called start OMCI test, and which internally call the Broadcom ONU, and from here the OMCI test action code we have already written long back. So this is once we connect here, from here the Broadcom Open OMCI ONU will initiate the start OMCI test action process, and it will implement that, and we will get the reply back. So this is the code changes currently I have identified.
Is there I assume since SIBA and NEM are on 1.7, you're talking about VOLTHA 1.7. Does that matter with VOLTHA 2.0? I mean, is this going to have to change again in any way with VOLTHA 2.0? Or are you putting new features into 1.7? Which VOLTHA are you implementing on top of?
Currently I'm targeting VOLTHA 1.7 because previous code for OMCI test action also written in 1.7. So this is pretty much compatible with VOLTHA 1.7.
So Sean, where are we going with that in terms of? I mean, we're not supposed to be doing new feature development on VOLTHA 1.7, right?
Right. So I think the Omkar is that can we target this as a VOLTHA 2.0 framework?
Yes, we can do that also.
Because I think the VOLTHA 1.7, Scott, I think that is basically, the technology profile is the last feature will be introduced in 1.7. So all the moving forward work should be on the VOLTHA 2.x.
Except I thought we are going to support BAL 3.0 on 1.7 as well, right?
The BAL 3.0, I think that the way the BAL 3.0 is working is against the OpenOT adapter, right? So potentially, whether that's 1.7 or 2.0 should be. I'm not sure on that part. 1.7, I think
the statement has been that there are no upstream of VOLTHA API changes for BAL 3.0. It's all below the adapter layer. This feature right here is causing upstream API changes on VOLTHA. So I think that's the difference.
I think, definitely, I think Saurabh probably would like to see the 1.7 support, using 1.7 to verify BAL 3.0 has fixed all the problem. I think that's the comment I would like to make. But since this work does, like Mike said, it is above the adapter level, so that will be, I think 2.0 should be the target for this function to be worked on.
Yeah, I asked Saurav about this a few weeks ago, and I think he said it was our choice which way we wanted to go with this. That the only disadvantage to 2.0 is that if there are any stability issues with 2.0, we would have to consider that 2.0 is maybe a bit of a moving target. But I think I agree.
Yeah, I think the question for me is if we keep putting stuff into the 1.7 branch. I mean, if you guys want to develop and test with 1.7, but not check it into 1.7, and simultaneously develop and test with 2.0, I mean, I know that's more work for you guys, but I think the problem is continuing to put functions into the 1.7 branch means we'll never leave the 1.7 branch, and the 2.0 branch will always be behind and will never be functionally in functional parity to 2.0. So I can believe Saurav told you that answer, but I think that's a problem, Sean, for us, that we're never going to kill the 1.7 branch if we just keep doing this.
Yeah. One thing is, because some of the, the global handler stuff you're talking about here in the presentation, the affinity router, they have that kind of HA, mechanism to set it up above the VOLTHA level, right? Above the VOLTHA core. So I think while you developed in this, you definitely need to take into consideration of the new framework on the 2.x design, because all the command you coming down, you have to go through the API server, which was called affinity router, right? So Omkar, can you take a look at the 2.x framework and see whether, I think it makes better sense to develop this on the 2.0.
Yeah, I think I need to check with 2.0 compatibility. The currently I targeted with 1.7 version, but I need to check whether how we can implement with the 2.0, because most of the architecture is new to me also. I have to look. So maybe I'll look it, and I'll definitely think get back to on this thing.
But
That'll be great.
This OMCI test thing is not there in 2.0, right? It's only in 1.7, I assume.
It is. I think the Omkar's previous the development is based on 1.7, but at the same time, I don't believe it's. I think it should be easy to to port that into 2.x, 2.0.
So
because the OpenOU adapter didn't change, right? The OM library that doesn't change. So I don't believe will be too big a difference on the ONU side.
So should we recommend to Onkar that his first step is porting his existing 1.7 work over to 2.0, or should he be trying to revise that work in favor of this more on-demand approach rather than porting the periodic implementation that he has now?
Can we maybe Omkar, can you do an investigation? Is that whether you can port it very easily into the 2.0?
Yes, I'll definitely look it.
Yeah, Scott, I think like we do want to focus on the 2.0 instead of the 1.7. Keep developing it.
Yeah.
I mean the key here is that and I can understand why Saurav made this comment is CEBA hasn't made a commitment to go to VOLTHA 1.0 or VOLTHA 2.0, but this feature is impacting features into VOLTHA. So I think if CEBA can do all of its work without impacting API changes into VOLTHA, I think that works just fine. But when you start adding APIs into VOLTHA in order to get stuff done, I think that's where you have to really consider bringing CEBA along to a VOLTHA 2.0 platform, even if VOLTHA 2.0 is less functional. I don't think we want to be implementing these new APIs on VOLTHA 1.7. Otherwise, VOLTHA 2.0 will never have we'll never have complete compatibility. So it's a gray area. I understand, and maybe we need to have a meeting with Saurav or whatever. But we gotta. It's a problem, and so that's why I raised it.
Yeah. I'll bring this up with Saurav and let him know what our thoughts are on this. Yeah, I think he's at a conference for a week or two, so we may find him a little harder to get a hold of, but I'll make sure he's aware. And yeah, that is one of the key issues, that SIBA doesn't yet support 2.0. I can't necessarily give anyone a timeline on when we expect 2.0 to be supported. Certainly there's some back and forth with David's new stabilization brigade that we may be focusing on before we actually bring 2.0 into SIBA. But I will let Saurav know of these concerns, and in particular that us not supporting VOLTHA 2.0 in SIBA at this time, it may be problematic for some of these development issues if people want these features tested in a SIBA context. Does that sound like that will address your concerns, Michael?
Yeah, no, I mean this is a key piece, right? In order to get FCAPS out of SIBA, you have to go do some VOLTHA work, and if we just keep spinning VOLTHA on 1.7, then we'll never make the cut. So yeah, that's the key issue. So I understand limited resources, and so we'll have to just kind of see how that plays out.
Yeah, I will get something from Saurav, and I will let people know what I hear from him, what his thoughts are on it. Did you have anything to present on Car? I think this was looking pretty good.
Yeah, that's it from my side. Once we decided the version, so I'll do other things.
Okay, yeah, I think even before we made a decision on that, I think you're exploring the 2.x framework and learning how it fits together and how the new affinity router and stuff like that works will be beneficial, because you're going to have to move in that direction no matter what. Eventually, the world is going to go to VOLTHA 2.0.
Yeah,
I'm going to be doing a lot of that probably this week too, is learning the 2.0 architecture. So this is kind of, a lot of us are suddenly finding ourselves getting up to speed on VOLTHA 2.x.
That's also the purpose here. And then, Carl, if you have any question, I think Dave Bridge from the Sienna has very good information regarding to the affinity routers related stuff. So, and then I think the Kent H from Sienna, I think he's right now handling the affinity router. So I'll send out the name.
Okay, so the next thing I wanted to mention briefly is Sean has asked us to do a discussion on the VOLTHA TST on the 25th of July. So first of all, Sean, you could just let us know what the scope of that discussion is. I assume it's the on-demand API and the world clock API.
Correct.
Any additional details, Sean?
I think that's basically yeah, that's the topic we'd like to at least have a wider audience, because I think there are more vendor participation on the VOLTHA TST calls. So I think we should bring up the proposal or whatever our assumption is, and then let them challenge us our proposal. That is the intent I would like to have.
Okay, so by proposal, you mean some combination of what OnCar presented this morning, as well as whatever we come to a conclusion on the world clock API.
Right.
Okay, that sounds good.
And then on the world clock APIs.
Wall clock is what I meant to
say. Still very fuzzy about that. Some OLT has local driver which will collect, fixed duration data, and some don't. I think that's the biggest problem right now we have, right? I mean, so how the VOLTHA will accommodate different devices which has different functionality locally.
Yeah, yeah. Are you guys seeing my screen?
Yes.
Okay, good. Yeah. So I started putting Sean's notes in as he gets them from vendors and operators. So we did get a response from CIG, and that did clarify how the implementation works a little bit. That there's a 32-bit register on the chip, in the hardware, and a 64-bit register in the driver on that particular OLT. VOLTHA talks to the driver, so VOLTHA gets the 64-bit counters. The driver pulls the chip periodically, and the driver has a configurable interval to prevent the chip's 32-bit counter from overflowing. So one of our tasks is to determine for all of the OLTs we want to support, do they also do this in a similar way? Do we get 64-bit counters from them? If so, that may influence our decisions a bit.
Yeah, one thing I'm not quite. I sent out a question back to Trey is the drivers, 10 to 30 second period. I don't know whether that's 10 to 30 second or 10 to 30 minutes. So since we're collecting the counter, for example, every 15 minutes, right? So potentially the 15 minutes counter already overflowed if this driver has such a narrow window. Does it make sense?
Yeah, my understanding, at least from what I read, is that maybe the driver is pulling the hardware every 10 seconds for that 32-bit register, and then putting that into a 64-bit accumulator, which we pull from VOLTHA. Under the assumption the 64-bit one is not going to overflow in our 15-minute interval.
That makes sense. Yeah.
That was at least my read of it, but yeah, maybe you want to respond back to him and just clarify that that's correct.
No, yeah, I think the way interpreted is that the driver will pull the chip register, every certain period of time. I think that makes sense too. Okay, yeah, I'll double check with CIG, and then we have some information coming from Adtran. I think Adtran seems to also have the software driver to do some of the work also. I think it seems to have some certain threat. So right now, my question back to the edge core, the counters provided by the BAO, I think it's the register on the chip counter. So is the driver provided by the edge core, is the OpenOLT driver or OpenOLT agent has a local driver, has a local counter to count those stuff, or current implementation, you don't have that?
I don't know if we have it in the adapter. We have to check it.
Okay.
We have to check it.
And not just adapter, right? So I think it's, so just on your, as I said, on the driver you created, on the edge core create, do you have a separate software stack to collect the data, the counter, and then provide the data to the adapter? So it's more on the device.
I'm talking about that. Are we caching the data? Is that what you're asking?
The what? Can you say that again?
Are you asking if we are caching the data in the drivers?
Yeah.
To be honest with you, I don't know.
Because I think the driver defined here is provided, come with the OLT device. Yeah, it will be interesting to know. I think I asked that question a little bit earlier regarding to whether the edge core, your software stack, do some additional processing on the counter or not, or you just.
I'm 98% sure that we don't cache anything on the driver or the adapter, but we have to check.
Okay.
Yeah, if we could just find out from you, for the API that VOLTHA is going to talk to, you know, do we get a 64-bit counter or 32-bit counter? I think that's ultimately what we care about. How it's implemented on the OLT itself is perhaps less important than just what data we get and when it's going to roll over.
Yeah, I think that's sort of, you know, if so Mike, I think if the software, the device driver come with the device itself, that's sort of on the left side of the graph, right? So where the counter is being accumulated, or the window bin, or whatever we said it. But if the VOLTHA is getting the raw register value and passed on to the right, then it's the right's responsibility to provide that wall clock related information, right?
Yeah, I am not of the opinion that we want to do that on the right. I think we've talked about that a few different times. Where my opinion of where it should be is it should be down in the adapter layer. I mean, if there's a hardware register that is looking at time and is saying, oh, something fired, and I switch to a different bin and I move that off to my current interval, and then I start accumulating the raw interval kind of mechanism where, and then VOLTHA comes down and pulls something out of a completed 15-minute window register, then you know, I mean, there are hardware mechanisms that do that. There are definitely devices that do that. If they don't do that, and if it's a matter of VOLTHA or I would assume an adapter. I would assume VOLTHA core is not sitting there going down and polling all these things at the right 15-minute interval. And if I don't read the right thing at the right time, I mean, I'm assuming that there's something in either the driver or the adapter. Well, I don't know. This is all confusing. I would like to see it. I would like to see it on the left. That's where I would like to see it, and I think I've said that for a long time. But I know that there's different discussions. I don't think just spewing data up and having some magic happen on the right that doesn't necessarily seem like the best thing for me. So I would hope that at some level, I think it has to be kind of at the driver level, that there was a driver adapter, not open OLT, not so like, let me say, not at open OLT adapter, but at some kind of driver adapter level, that, you know, I'm making a 15-minute interval, and I'm have it all set, and it's counted, and I know that it's 15 minutes worth, and then, you know, maybe I'm accumulating the raw data at this time until that current interval is read. I'm hoping that's down somewhere pretty low at the left, but you know, maybe it's not. I don't know.
Yeah, so Scott, I'm also asking Tibet to provide input, because their device and is very different, right? So they have, you know, probably not that much. They have enough, but not that much processing space on the chip itself. So I think that maybe that's a wrong statement.
The chip definitely does not hold a 15 minutes worth of data, nor does it hold multiple 15 minutes worth of data, current and previous. Yeah, external software has to be pulling that off and binning it externally. And I hope that that's not all the way off onto the right. I hope that that's some driver level Tibet implementation below OpenOLT adapter, that then, you know, somehow OpenOLT adapter can come down and get a 15-minute interval and post it up on a Kafka bus and send it on, or, you know, get a real-time read of a current window or something like that. I'm hoping, my hope is something like OpenOLT adapter is simply either give me at the 15-minute interval, give me the data, or, you know, on demand, give me the data and get a response. And it's not that the OpenOLT adapter is not the one that's responsible for accumulating and binning and doing all that stuff. I'm hoping that it's at the driver layer or below, but I mean, or I don't, adapter driver, I don't know how many adapters we have or how many drivers we have. I don't know what the right necessarily I don't know if I know all the right terminology there, but hopefully it's not at the open OLT adapter that has to do all of that binning and all that management of the clock. I don't know.
So Scott,
I think that's what we have said previously. I know that there are other opinions that we should just push it all up and let some magic time series database figure it out for us, but that's not where I'm at, but that may be where others are at. So
yeah, I think we're missing David from this morning's call, or perhaps he would be advocating in that direction. Yeah, so I guess where I'm at is we need to, for the July 25th, we need to have some kind of a proposal. It seems like we need to settle on this issue and figure out how we're going to accomplish this. Michael's request sounds like a reasonable one for functionality to provide. Provide it on 15-minute intervals, stopping at a wall clock. It's just where does that happen in the stack with regards to left or right? And the more information we can get from the hardware vendors as to what abstractions they can give us to the device, I think that's helpful. But I think the key question is, what if someone does come back with us and say the most you get from us is, in the absolute worst case, a 32-bit counter that rolls over every 30 seconds. And it's up to you, VOLTHA and VOLTHA adapter guys, to figure out what to do with that to make it useful. What do we do in that case? Where do we implement that binning if we need to implement it ourselves?
And I guess my point on that one is maybe we need an additional software layer. We need an adapter, because I wouldn't want it to get that implementation to get into the open OLT adapter. I hope it wouldn't get that high. If they're saying, here's our driver, and we're not going to give you guys a driver that meets any kind of interface spec on. I would like to say that here's the driver's interface spec. The driver's interface spec is able to provide 50-minute intervals, either on a clock or on demand, and here's the driver's interface spec, and this is what you guys have to provide. And if your hardware doesn't provide that, you guys have to write some software that would do that. If people are going to balk and say, I'm not writing that driver software, then someone has to go write that software. Hopefully it doesn't have to get sucked into open OLT adapter and clutter up open OLT adapter, because I think that you just lose all sense of abstraction if you have to go implement every single person's kind of, well, this is the way I do PM, and this is the way my counters work, and let's put it all into open OLT adapter and make it I don't know. I hopefully it's not an open OLT adapter. That's my hope.
Hey Scott, I need to drop. So I'll, we can. I really wonder what would be the best way to collect information from different various vendors. It seems like the way I work probably doesn't really get a very effective discussion out of the vendor side. Maybe I'll check with you, but I need to drop right now.
Yeah, just a quick question, if you have a moment, Sean. Do you think on the 25th, if our discussion, if we ask the vendors at that time, please get back to us, what can your driver do? What can you add to your driver to give us this capability? Would that be appropriate for the discussion on the TST, or should we try to have this sorted out before then?
I think that probably will be the latest time we'd like to discuss. So, but at the same time, no, I think it's a good forum. Just discuss in open if they want to participate. If they don't want to participate, then nothing we can do about it, right? So maybe just target, and then I'll make sure that some of the device vendor to show up on the 25th meeting.
Okay, that sounds good. Okay. Well, okay, thank you for participating this morning, Sean. We've got like 8 minutes left, so we'll talk a little bit more, but I'll let you know over email if anything comes up. So Michael, just so I can wrap my head around this, if our position was that from the device manufacturers we would like an API that gives us binned wall clock time, We will pass that binning abstraction up through OpenOLT, push it onto Kafka or whatever out of the NEM. But if you don't give us that binning abstraction in your hardware by the device vendor, then we will push the best thing that you do give us. If you give us a simple accumulator, we'll push that up through our layers instead. Is that an acceptable position?
It's not for me. Other people can vote. I'm not the final vote. For me, I think that we need to define an API at the driver layer that says this is what you have to provide to VOLTHA with software in your software driver. Now, if your hardware doesn't do it, then you got to write some software to do it. And I mean, fine, your hardware's your hardware, but otherwise the driver has to provide that. I think we should set the API at the driver layer of how PM is going to be presented, and giving VOLTHA a very specific way of pulling it. Here's how I get the current 15-minute interval, and here's how I get the current real-time accumulating interval. So I can always come down and get a 15-minute interval, and then I can get the current raw counts. And however their driver has to implement that, and this could be OLT, ONT, ag switch, whatever thing that's going to have a 15-minute interval. I think we should be able to set that API on the driver and say, this is how you need to do it. And someone needs to write some software to do that. Now, if they say, well, we don't want to write that software, well, then someone's got to write that software for that device, for that driver, so that it can interface properly into VOLTHA. That's my opinion of how it should work. And there can be others that say that, no, here's a much better way to do it, and we can vote and the community can decide. But, you know, my opinion is that the API should be at the device driver layer that says this is what VOLTHA is expecting for PM. And unless somebody has something else, I think you should be able to get the current accumulated 15-minute interval based on VOLTHA being able to provide the wall clock and synchronization clock that says, you know, here's your clock, here's when 000 is, and here's when 15 is, and so some mechanism of communicating when the clock changes. So I should be able to get my current accumulated window, and I should be able to get my real-time currently accumulating window, and you should have APIs that do that. That's what I see would be needed. But that's Mike's opinion. So if you want Mike's opinion, that's Mike's opinion.
Okay, yeah, I'll probably summarize this out on the email thread. Yeah, so I guess the position then is that we will define the API. We will tell device manufacturers either you deliver us this API or we will task someone to implement it at a layer beneath VOLTHA. And then resources to be determined as to who would implement that, if not the device manufacturer.
That would seem to be the best thing to me. And obviously, as we've had many meetings, obviously others have different discussions. But that's Mike's opinion. I think Tom is on board with me on that. I didn't say that's AT&T's opinion, I guess.
Okay, I will. I'll jot that down. Do we have anything else people would like to discuss? We're almost up to the top of the hour. So what I will do is I will try to summarize these thoughts. I'll try to put your opinion in writing, Michael, and then that'll give David an opportunity to respond, because he may have the other opinion about doing it all the way at the right. And then we'll try to come to a settlement on which way to go or whom to put it to a vote to over the next week or so. How does that sound?
Yeah, I'm working till Friday, and then I'm on vacation for 2 weeks. So I don't mean to that's just a statement of detail. So if we don't, and I'm not expecting us to get this all wrapped up by Friday. So I'm just saying that I won't have a vote. I won't, and Tom can represent AT&T. Tom can vote if you need somebody to vote, and so Tom will be around. Yeah, so I've got vacation coming up, so that's where I'm at.
And to let everyone else know, I am on vacation this week from Wednesday through Friday as well, so I will be out of touch a little bit. I'll still be reading emails if Ankar, Ganesh, Dinesh, if you have a question and you need help. I'll be reading emails, but I'll be mostly out of it for the later 3 days of this week. Yeah, so I'm gonna try to get some of this written up today, and maybe we can pass it around a bit today and tomorrow. And then Michael, I'll make sure we have someone to represent your opinion on the 25th, and that we don't vote without your input.
Okay.
If we voted, I mean, I'm not sure we're going to be voting it on the 25th. Maybe it will be a discussion that will kick off a future vote. But yeah, we want to make sure everyone's opinion gets heard on the issue. Well, I think that's it for today. Thank you everyone for coming.
Yeah. Thank you.
Thank
All right,
you.
thank you.
Bye, guys.
Bye.
Bye.